Today I'm at PDAC Toronto 2024, and I'm going to be speaking with Pat Ryan, the president of Ucore. So over to you, Pat. Tell us, what is Ucore doing right now with regard to its rare earth permanent magnet total supply chain? Because I know that you're developing various aspects of the chain, and you've had some successes in various parts. So tell us about it.
Yeah, a great question. I think as people know, we're focused on that mid-market where separation is key. And we're using our RapidSX technology, which is a column-based technology that deploys the solvent extraction as used in mixer settlers. It deploys it that much more effectively. So you get throughputs that are 3 to 10 times better than we're measuring. But our commercial demo plant in Kingston, about 2 hours from here, we've been running different materials through. We've been testing and tweaking the commercial demonstration system as we engineer the full-scale system. And as you know, permanent magnets, they work with your NdPr and your dysprosium and your terbium. The one critical thing that we're really focused on, Jack, is that heavy rare earth element. There are a lot of players evolving in the West that are making NdPr, getting close to making NdPr. It needs to feed downstream into the supply chain, that's obvious, but the heavy rare earth is still missing. We had a news release this morning where dysprosium is at 99% plus, using our RapidSX technology, and we are producing kilograms of it. Within the next 3-4 weeks, we'll have a lot more dysprosium to actually then distribute to customers that are looking to use it to make those permanent magnets. And as you know, the permanent magnets, they really only work because the heavy rare earth allows it to operate at a very high temperature, such as in an electric vehicle.
Where are you getting the feedstock for these heavy rare earths?
Well, the feedstock is coming from the Asian market, not China. And we run some xenotime, we run some bastnasite, and this happens to be an ionic clay, and it does come from the Far East, but not from China. So you can kind of guess where that might be, but I'm not going to come right out of my comfort zone.
And how much dysprosium oxide have you produced, or whatever compound of dysprosium? Tell me.
So we just started separating today. And you'll see in the news release that we're running our raffinate through, we're running our strip liquors through, putting them in 5,000-gallon tanks. So there's many gallons of this material containing dysprosium. And by the time we're done processing it out, we'll have kilograms of dysprosium to be used for our customers.
To be honest with you, the first time I bought dysprosium was 1962, and it was in grams, and it was made by the biggest ion exchange columns I ever saw in my life with feedstock from Africa. Okay, so since then, I don't know that anybody's really been producing it in North America. I suspect if you're talking kilograms, that's commercial. Yes. Okay, and I think you'll be the first commercial producer of dysprosium materials in the United States at that level ever.
Well, this is a commercial demo. And as you know, the engineering is being done for a full scale. And our full scale plant will run heavies in a much bigger quantity. In fact, we're targeting somewhere in the order of 900 tons out of that first Louisiana plant. So 900 tons of heavy rare earth. And feedstock is always an issue. You've got to find it. You've got to strike up your deal. We're not in a buy-sell arrangement with a feedstock company. We're looking to joint venture appropriately. I think that's what the West needs to do. If you try to take each node of that supply chain and get your economics to work very soundly, it can be a challenge. Now, our RapidSX technology is really robust. The CapEx is bar none. The OpEx is really great. It's where we need it to be. But we're not going to be a standalone tolling house. So therefore, we're reaching upstream to the feedstock companies and say, let's work together and have a value proposition together to move forward. So yeah, significant quantities of heavy rare earth that we can then supply to makers.
And when do you hope to have your Louisiana plant in operation?
In 2025. The engineering is going on right now. We have Orbital Engineering, who are out of Pittsburgh. They have an office in Baton Rouge. They're working on the engineering of the scale-up of our RapidSX tech into a building that we have in Alexandria. And MetChem out of New England. They build chemical plants around the world, and MetChem is involved with us, as well as Kingston Process Metallurgy, who are a very valuable partner that we have currently in Kingston. And all of these people are working together to take a copy and paste what we're doing in Kingston. We've got what we call a RapidSX machine. We're going to build 7 of those in Louisiana to get to 2,000 ton per annum ex-serum, ex-yttrium. Then we'll build another 7, and then we'll build another 7. So eventually we'll have 7,500 tons total.
What's interesting to me is that while everybody else is talking about it, you're actually doing it. That's a big difference. And what's intriguing to me is that certain entities of the U.S. government have thrown money, invested in various internationally known large non-Chinese rare earth producers who haven't even broken ground on a plant to process heavy rare earths. And in fact, they won't tell us where they would plan to get them. So the only plant I see producing heavy rare earths in the United States anytime soon would be Ucore.
Yeah, and I know the other entities you're speaking of course. And you know, when you're building out a plant, you've really got to be robust on your commercial workup. You've got to be really robust on your engineering. That you're not putting a couple of Bunsen burners and some shake flasks on a table and trying to make something happen. The plant we have in Kingston is the size of about 2 tennis courts. We've invested in excess of $10 million in the last couple of years to get that thing fine-tuned. And when you think about it, it's really it's like machine learning in that on the front end we have your process that happened, you load it up, you do your separating. But in that separating, there are 600 sensors, there are pumps, there are PLCs, pH controls and whatnot. And on the back end, you have people taking it out. So that whole machine in the middle, which is a column-based tech, doesn't have people in there with mixer settler tanks and watching every part of the system. It's all really controlled. So when I say machine learning, it means that as the RapidSX technology, as the machine continues to process, it's gathering lots of data over and over and over and over and fine-tuning and fine-tuning and fine-tuning such that we can put multiple feedstocks into the plant.
This really tells you more about you than anything else. Pat, how long have you been a manufacturing executive?
I've been a manufacturing executive in the automotive industry for, dare say, 30 years. I was a very young mechanical engineer when I started a tier 1 automotive company, and I do understand the intricacies of building manufacturing plants and building product to spec. I'm always a little surprised, if you will, by people that talk about, we're going to make this concentrate and the automotive company is going to buy it. And it's like, well, that's actually not what's going to happen. And even if you think they're going to buy it, they're not going to buy it like that. And you know things like PPAP and all the requirements to get something in a supply chain that actually then meets the different tiers of supply, so that they know when a magnet gets made that goes into an electric motor, that magnet is in fact on spec where it needs to be all the time, every time.
You know, you couldn't be more right. I always tell people, it doesn't really matter if you're supplying salami or motor parts. There are specifications, there are procedures, there are rules, and the most important thing is you have to deliver on time to spec, the agreed price, and the quantity. Okay, and this is the issue. So I think that your particular background gives you a real leg up on this, because you're credible to the automotive industry because they know you. You've been a supplier for what, decades?
Correct.
Of
yes.
Large amounts of material.
Yeah, one other theme that I heard you speak about recently, Jack, which I think is really true to the automotive industry. It happened when remember when the door blew off the Alaskan jetliner plane? And I thought, oh wow, is Boeing ever in trouble? And the CEO stood in front of a group of reporters and he spoke about what they were going to do to fix that issue. And the one thing that hit me was that he said, we're going to fix this really quick because we own our entire supply chain. And I went, oh my God, that's what the automotive companies used to do. They used to own their entire supply chain. And now we've got these little fragmented pieces starting to come together, but it will have to go back to owning your supply chain.
I think that's right. I saw an announcement about a week and a half ago that Ford and GM were going to do something together on EV components. Okay, now that's talk, but it's a start. And as you remember, all the car companies made all of their parts 30 years ago. Then they decided just in time was better, and they could also hit the suppliers for lower prices, get rid of UAW, all these good things. And they sold off Delco, they sold off Mopar, they sold off Promoco, okay, and now the wheel has turned, and they're getting bitten, you know where.
Absolutely.
Okay, and the only difference now is that the components are more complicated than they used to be, and you don't just take a blueprint and build a factory. You're going to have people. You're going to have a time where you learn how to do these things.
Correct.
And we're talking years and billions of dollars, and I don't know how they're going to do that. So,
well, it is what has to be done.
yes,
right?
absolutely.
It is
I
what
couldn't
has to
agree
be
more.
done.
So, my guess would be that someday you'll probably sell Ucore for a lot of money to Ford, GM, or Stellantis.
Possibly, you know, we're trying to build that vertical integration, not just be one node. And I really believe it's ultra important to joint venture with your partner in the supply chain, because you've got to have that shared profitability. And I think the Australians call it the pain gain model.
Yeah.
And so, you know, you win together, you lose together, but you work together because you're trying to maximize your throughput, and your value proposition together is that much more effective as well. And you know, you look at BYD, you know all about BYD. They own their supply chain, just like Boeing owns their supply chain, and the North American manufacturers need to catch up.
You know, the key thing in the Boeing announcement was that they're buying back the fuselage maker that made that unit. Okay, they sold it off for just in time and all that, and now they're taking it back. And I think you're right. In the long term, they'll go back to Model A instead of B.
Yeah.
Okay, and listen, thank you. This is way too much here. The viewers are going to have to think about this, because Pat actually knows what he's talking about, which is very rare in this business. Thank you, Pat.
Thank you, Jack.